Good morning, good afternoon, and good evening, everybody. A big welcome to you. A very exciting announcement today. I'm David Reiner, the president of SPEC, and I'm going to give you a little bit of background on SPEC before we get to the chair of our SPEC CPU committee to give the big announcement today. So welcome. So SPEC, hopefully you're already familiar, but SPEC, the Standard Performance Evaluation Corporation, we've been around for almost 40 years now. We are one of the leading industry standard organizations for benchmarking. We create benchmarks for 35 different types of benchmarks. We benchmark many different things. As people say, the best benchmark for you is the one that's most relevant to your workload and what you do. So we have many different benchmarks for different focuses across server, across embedded. We're going to talk about those in a minute. And we are committed to vendor neutrality. So SPEC has many processes in place developed over the decades. We have multiple levels of the organization for checks and balances. So we have a very rigorous organization dedicated to the highest quality benchmarks. We also, more than a decade ago, started our research division and had partnered with academia even before. In addition, we have the International the International Conference on Performance Engineering that's actually happening next week in Florence, Italy. So that's very excited, and hopefully you'll check that out as well. So to move on here, SPEC is an international organization. We have over 120 organizations from all around the globe. You can see here, this lists the headquarters of our different organizations, but as many of them are multinational organizations, we have participants from many more countries shown on this map. Talking about our list of benchmarks that I was referring to, at the top we have some of our embedded benchmarks. Actually, in the last couple of years, the third or fourth consortium joining forces with SPEC was the Embassy Consortium, and they brought their high quality suite of embedded benchmarks. This CoreMark you've probably heard of before, and the AudioMark, IoTMark are some of the other benchmarks focused on embedded processors. We also have our graphics and workstation group that has SPEC workstations, SPEC APC benchmarks that focus on the applications, some CAD, CAM, and other professional applications, as well as SPEC VPerf, our leading benchmark there that replays traces of the graphic streams from different professional workstation applications. We also have in the server space quite a few different benchmarks focusing on different subsystems and areas and software stacks. We have SPEC Storage, SPEC Cloud, the Java benchmarks, SPEC Vert, also SPEC Power looking at energy efficiency, HPC that looks at supercomputer high performance computing, and what we're talking about today, SPEC CPU. So another exciting thing that started some years ago with a request from the US EPA was the use of SPEC benchmarks in energy efficiency regulations. So on the server side, over 50% of the world's servers have to meet a mandatory energy efficiency requirement, and some countries have idle power requirements as well in order to be sold in their country. And these governments have chosen SPEC as the benchmark that they want to use to evaluate and set these thresholds within their regulations. So you can see we also have for the US Energy Star program, SPEC Storage, as well as SPEC VPerf, our benchmarks in that program. And there you can see a list of the other countries that are using SPEC benchmarks in the regulations, as well as SPEC CERT. The server efficiency rating tool is the only test method for the ISO IEC international standard there, 21836, which is a very SPEC is very proud of. So with that, I'll hand it over to our esteemed chair of the SPEC CPU committee, Frederic, over to you.
And thank you, David. I'm happy to talk today about SPEC CPU. So my name is Frédéric Silbert-Chaussumier. I will be talking on behalf of the SPEC CPU committee. And a few words about this committee. So this committee is part of the Open Systems Group from SPEC and is composed of members which are coming from leading tech industries as well as nonprofit organizations. And we also have a few individual contributors in our committee. So to start with some background about the SPEC CPU benchmark. So the primary focus is to assess the computing performance of the systems with its interaction with the memory subsystem. So we focus on general purpose CPUs, which means that we focus on CPUs inside servers, but also PC, workstation, up to mobile CPUs. Another aspect of the SPEC CPU benchmark is that it's also used for compilers. So it's actually let to the end user to pick up how the binaries that are used inside SPEC CPU are built. So the end user might choose to have binaries which reflect the performance of daily applications which are distributed on their systems. And for this, they might choose their platform compiler with, let's say, widely used optimization options. But the end user may also want to measure the peak performance that the CPU can achieve. And for this, might go into more advanced compiler options. At last, so SPEC has a well-defined, strong, widely used energy methodology, and that is also integrated inside SPEC CPU. So you can report the scores of the benchmark, but also energy measurements. SPEC CPU is composed of 4 suites, which are divided in 2 categories, SPEC rate and SPEC speed. So SPEC rate is about running multiple copies of an application on a system, and it can scale with the size of your system, which means that you can choose to benchmark a single CPU, and you can do this by running a single copy on your system. Or you can choose to benchmark also the throughput of your whole system by starting as many copies as there are cores in your system. So the SPEC speed suite is different. So you will allocate the full system to running a single application. And this single application will use the resources of your system, usually using internal parallelism from your application. And SPEC speed is designed for bigger systems, so it's running longer and using more memory. So to build this benchmark, SPEC CPU has a stable, strong principle, and the first of them is portability. So the goal of the SPEC CPU benchmark is really to run on as many systems as possible. So it's extensively tested during development on many different systems. So it's tested on x86 and ARM, but also on Power and RISC-V. It's tested on different operating systems, so Linux and Windows, AIX, and macOS. To achieve portability, there are strong requirements during the development. And for instance, we enforce compliance with language standards. And we also do not use platform-specific code paths. So the second principle for SPEC CPU benchmark is reproducibility. And reproducibility at actually 3 levels. So the first level is from within the application, where we want the application to be reproducible. So we remove sources of non-determinism from within the application. Then we also take care of minimizing the run-to-run variation. But in order to go further into this direction, what is recommended is to run several iterations of each benchmark so that the produced score is stable in the end. And at last, SPEC focuses a lot on disclosing the performance methodology. So it's reproducible also in the sense that if someone claims a score, it should give you the full disclosure on how the performance was achieved so that you can reproduce the same score on your end. So the next principle is about comparability. So it's all about having equal work across platform. So to do that, so we align everything across platforms. So we align data types, we align code paths, and we also make sure that the execution behavior is the same across platform. So for instance, aligning on random generators, removing undefined behaviors, and also trying to not rely on algorithms which are too sensitive to floating point accuracy, for example. So the next principle is that all benchmark comes with validation. So we make sure that during this validation process, we make sure that the work is done and we make sure that the outputs of the programs are correct. And at last, what is very important for SPEC CPU is that the chosen benchmark are representative. So they must come from real applications which are popular, which are an active user base. And we also pay attention to the fact that the way these applications are used inside the SPEC CPU benchmark actually represent the way that they are used in the field. So these are, you will see there, these are real applications with a lot of lines of code and not kernel or micro benchmarks. All these principles are supported by rules. So there are two kinds of rules, the run rules and the fair use rules. So the run rules will explain in detail how the measurement should be done. So I already cited two of them. So for instance, that it's recommended to run 3 iterations per benchmark. You need to have also a full disclosure of how you run your benchmark. And at last, another rule, for instance, is the performance method maturity. So we recommend that you use hardware, operating system, and compiler, which are maintained, documented, and supported. The second set of rules is fair use rules. Fair use rules will explain to you how you can publicly use the scores that you produce with the SPEC CPU benchmark. And so it will give you, instead of saying just the score, it will give you a fully identifiable metric, which might be called, for instance, spec rate 2026 in base, to be able to remove ambiguity on what you run and to be able to provide comparison which are meaningful. So with all these principles, SPEC CPU is actually used very widely. The first set of usage is because our computation systems are very complex, SPEC CPU encapsulate this complexity within a few metrics. And these are useful, for instance, to establish a price of the system or to explain the price. And we also help buyers in their purchase decisions in order to compare the different systems. On the engineering side, so the chip designers from the infrastructure market to the client market can use SPEC CPU to design their CPUs. And there, what is really important for them is that the benchmark is able to cover a wide range of applications, the wide range of domains, but also have hardware profiles which exercise all the part of the CPUs. On engineering still, in compiler teams, SPEC CPU can be used and is used to have new ideas for optimizations, to test new optimizations and the performance of the generated code, as well as when integrating new instructions to test the generation of the new instructions and test their validation. A consequence of the full disclosure of the methodology is that when you buy a system, you can reproduce the performance that is claimed, and so you can validate that the system is performing as expected. And at last, SPEC CPU is widely used in the academic research, and SPEC values a lot innovation, and part of the tremendously high work done on portability on SPEC CPU side is useful on research sites to be able to run on prototypes and less advanced systems. So another aspect that helps this usage of SPEC is actually SPEC is not only providing score, but it's also providing a whole set of tools which will help you investigate and understand the performance that you get. All this has not been done in one day, and so SPEC started almost 40 years ago and adapted along the years. So many adaptations happened. So it adapted first, for instance, on hardware side by introducing floating point suites in 1992. More lately, it adapted in SPEC CPU 2017 to add power efficiency metrics. And all along these years, what SPEC did is adapt to the software and to the applications that were run at those times. So you can see here that the number of lines of code in SPEC never stopped increasing. So, and doubled between 2006 and 2017. You can also see that there is a trend in the increasing in number of benchmarks. So started in the past with 10, 20 benchmarks, and now we are around 40 benchmarks. Also, we have a set of published results on our website, spec.org, and the yearly published results also always increase. And with that background and with that said, I'm happy to announce now the release of SPEC CPU 2026, and this is a major release of SPEC CPU. The first and very important new things into this SPEC CPU 2026 is that it covers many new applications. So we integrated many new applications into this SPEC CPU benchmark, which are more modern, which means that they are currently very actively used and also cover more domains. The number of benchmarks increased, so there are now 52 benchmarks, up from 43. And the number of lines of code also increased a lot, more than doubled, to go to 17 million lines of code inside SPEC CPU. We also paid a lot of attention to cover hardware profiles, which are very diverse. The other change is in SPEC speed suites. So the SPEC speed suites increased in their requirements. So because today's systems are even bigger, so the memory requirement increased to 64 gigabytes. But mostly now, almost all the benchmarks which are in the SPEC speed suites are parallelized. They are parallelized now with different techniques. So we support OpenMP as we did before, but we added C++ threads and Fortran parallelism also inside the benchmarks. And on top of that, some parallelism is executing using multiprocessing. So that's for the content of SPEC CPU 2026. And we also made some changes inside the run rules. So we added support for bare metal cloud platform to allow people to submit results using cloud servers. We also are encouraging community compiler results. And so for this, we added a new field in our results, and we refined the rules on compiler optimizations. And at last, we are now supporting a new experimental mode for spec rate to allow to start a different application on each core instead of the same copy of the same application. One step back about the development of SPEC CPU 2026. So it started in 2020 within the search program, and a lot of applications were considered. So about 90 applications, and 38 different ones are currently in the kit. So the way we worked within SPEC committee is that the committee members all together work at establishing the benchmarks. And when benchmarks come in the search program, so are proposed by some authors within the search program, so it's taken inside the committee, and as they arrive, we start integrating them into the SPEC CPU benchmark and evaluate how they fit to our requirement in terms of runtime, in terms of portability, and all I have described before. So it's a constant community effort within all the SPEC CPU members and their authors and the authors of the benchmarks. So I would like to thank all our contributors. You can see many of them coming from leading tech industries as well as non-profit organization, and I don't want to forget our contributors also. So let's deep dive into the core of the SPEC CPU, which are the benchmarks. So they are represented here in two categories, and I will start with the first one. And I will start with the flagship benchmark for SPEC CPU, which is GCC. So GCC has been present since GCC 1 and has been updated in each SPEC CPU release and is still present there. But you can see that it has been joined by another compiler and also a fully renewed set of applications which are very popular. And if you look at this category only, you will see that this one is already a lot of lines of code. Then looking at the compression and media category, so here again, it's been very much renewed with industry standard tools. We also have an artificial intelligence category, which has been modernized. So we have 2 games and 1 translation machine program there. And the next category is brand new, so wasn't existing at all in SPEC CPU 2026, with standard research tools, which are very big, very wide in terms of lines of code. And on this tool an special effort has also been made to have very relevant use cases inside. And the next category is about simulators. So we extended also the simulator that are present in SPEC CPU with a new simulator and also use cases. So I mentioned before these use cases. So when exercising a benchmark, when the applications are large and pretty generic, there are several ways of exercising this application. And this is what we call use cases or workloads. And in SPEC CPU 2026, there is one novelty is that the number of workloads within each benchmark is a lot higher than it was before. So it's a lot more diverse than it was before. And there is also in this same category a security application. The next category has been also fully renewed there with a very popular database, and it's about database and analytics. Moving on with the next categories, so they are more on the computational side. So biology and chemistry has been augmented also with 2 new applications. Physics and engineering simulation has been a lot extended with many new applications inside. And at last, with all this new application, now the dominant programming language inside SPEC CPU is C++, but Fortran is still present, and particularly in this last category, astrophysics and geoscience. So 3 new applications in this category. Several of them are in Fortran there. So to conclude, I would like to give you a few more information. So SPEC results, SPEC CPU 2026 results already exist. You will find all these results are kind of various. So you will find servers results, but also workstation, laptops, and even a Raspberry Pi. These are the initial results. You will find the next set of results on the 4th of June, which will be published in our website. And little by little, on a very specific schedule, SPEC CPU 2017 will be retired. You may find out more and all this information on our website. And to conclude on a welcoming note, so if you want to participate to SPEC CPU and the next SPEC CPU, please come and join us in the SPEC CPU committee. Thank you very much, and thank you for attending.